Okay, there was one question I wanted to address in the chat that I saw, which is that were we supposed to do any prep for this session? And no, you were not supposed to do any prep. One thing I asked you to do was that you should have signed on to RStudio once. This is not required per se, but I am going to be using RStudio Cloud as a student to go through a data exercise. And so what I'd like you to do is, if you would like to, you can follow along with me if you want, okay? Are there any other logistical questions before we get started? Let me just scroll through. Would I like to talk about the use of data science in the real world? Sure, I'd love to talk about it. I can say a few things kind of quickly now, and then that's, you know, a lot of the examples that we're going to give will be kind of about how data science is used in the real world. But are there any particular like application areas people are interested in hearing about? I'm trying to think. So let me try to give you guys a couple examples, maybe a few fun examples of what you might do with data science. So and then we'll get back to today's exercise. So I'll start with some fun examples, and then we can go to slightly more serious ones as well. But I'm going to share my screen. Here we go. Okay, so I'm going to share my screen and share with you one of the blog posts that I really like that might give you some idea of some uses of data science. So this blog post is actually about 4 years old, from 2016, from the time of the 2016 election. So this was during the campaign for the 2016 election. And I don't know, I think at this point, it's kind of impossible for people to not know about kind of what's happening in terms of politics in the US, even if you don't live there. But at the time that of the 2016 election, I was living in the US as well, so I was following it very closely. And I think one of the things everybody in the world knows about is that Donald Trump tweets a lot, right? That's, I think, something everybody knows. So David Robinson, who is a data scientist at a company called Heap Now, who writes a lot of R and Python code, actually what he did was to scrape data from Twitter, which you can do with an R package. There's an R package called TweetR, and there's another R package as well called RTweet that does this. So using these R packages, he scraped some data from the real Donald Trump account. And I'm going to, and then did some text analysis on this. So I'm going to scroll down to one of the interesting results from it. So one of the questions is, what is an R package? So I have two answers for that. One of them is that is answered in one of the videos, but the other more helpful answer is that R packages are how people who develop our code, so open source developers who develop our code, share it with the rest of the world. So if you implement something new that you want to share with others so that they can also use your code to do things in R, you can actually do that as an R package. So that's what an R package is. And so somebody who has decided to develop a package that scrapes data from Twitter shared it as an R package called RTweet, TweetR, I think was the name of the package. And so David used that to scrape data. And another thing the Twitter data gives you, so if you get data out of Twitter, one of the fields that it gives you is what kind of a device the tweet came from. Okay, so some of the tweets on the real Donald Trump account came from an Android device, and the other one came from an iPhone device. What this means is that there are two separate people probably tweeting from this account. And for most kind of prominent people and celebrities, this is true. Usually they have either like a PR person who tweets for them, and then they have, they also tweet themselves. So here are the words that came from the Android account that didn't appear in the other account. Things like badly, crazy, weak, and whatnot. And on the blue side are the terms that came from the iPhone account that didn't come, so that didn't really appear from the Android account. So we're looking to see not what words are in common between the two accounts, but what words are different. So looking at this, what would you guess, Android or iPhone, is what Trump uses as opposed to his campaign staff uses? I think so, yeah. So it looks like Android. So so this is one application of data science. So what did we do here? We scraped data from a data source, in which case Twitter, and then we did an analysis using a text analysis method, which is actually one of the things we're going to cover at the very end of the semester. I'll give you one kind of lesson on doing text analysis and language processing. So this is the sort of stuff that you can do. If you think about it, this sort of methods are the ones that are used for, ultimately, they're the same methods under the hood that are used for being able to understand human speech, for doing things like speech to text. So these are all interrelated topics. This just happens to be a fun application of that kind of technique and the application, the methodology. Does that make sense? Okay, so what we're going to do today is I am going to pick a data set each week for these code along sessions, and I'm going to use that data set to exemplify topics that we're learning that week. This week is a little bit different because I haven't actually started teaching you a whole lot of R code. So I kind of want to give you an overview of the ecosystem. And I'm going to try to set a timer for myself. So around like 5 minutes to noon, I'll stop doing things and just like make sure that we have enough time to like rehash everything that we said. But I don't have a particular agenda. So my goal is to, and I haven't prepared a whole lot for it other than picking a data set. So my goal is to ask you to guide me as to what are the types of things you want to learn. So the data set that I've picked comes from this project called Tidy Tuesday, and I wanted to use this as an opportunity to let you know about this project as well. So Tidy Tuesday is a weekly data project in R, and there's an online learning community for R for DS, which stands for R for Data Science, which is the book that we actually will be covering in this course as well. So there's like an online learning community. They have a Slack channel. There's a lot of people who help each other for learning R. And one of the projects they put together is each week they pick a data set and they release it to the world. And people who work with R try to do visualizations or other stuff, modeling, what have you with these data sets. And the best place to find out about what people have done is actually on Twitter. The Twitter community for R is very vivid. So I'm going to look for Tidy Tuesday here as the hashtag. So each week on Monday, there's a data set released. And usually on Tuesday, there is, people try to do visualizations using this data set and R, and then tweet about it. So you can see kind of just an example of a couple weeks ago, there was a data set based on the show, like the script of the show Friends, like for all of the seasons. So people worked on that. This week's data set is on people who climb the Himalayan peaks. So that's what we're going to look at. So I'll just share this with you as if you want to peruse through it or participate, this is out there for you. And I think it's kind of nice to see what are the types of visualizations you can do with R. So R is the programming language that we're going to be learning in this course. the link in the chat? Sure. And so let's go ahead and put the link in the chat. Here we go. So what I've done is I am going to take a look at the data set. So you can see each week there's a data set released, and these go back to 2018. So that's a lot of data sets. Last year, many of the students who did their final projects decided to use data sets from here because it was easy enough to get it and there were interesting data sets. So this might be a resource you go back to when it comes time to doing your your project proposal as well. So we're going to work with the Himalayan climbers data set, which is the most recent one. And the data set actually comes from a database called the Himalayan database, which is maintained by Elizabeth Hawley, who is a journalist based in Kathmandu. So if you know anything about the Himalayan peaks, there are people who are climbers who travel all around the world to go there. And then there are people who live there, who are like Sherpas, who are hired to basically assist these climbs. And some of these climbs are successful and some of them are not successful. So we're going to be looking at, kind of how these particular, the expeditions, the people who climb them. So there are 3 data sets we'll use: the members, which is about the people who climb them, the expeditions, individual expeditions, and then also the peaks. Okay. So I'm going to put the link to this. I'm going to put a link to this in the chat so that you can open it, so that you can take a look at the variables. And what I'll also let you know is that I have created a project on our Studio Cloud, and I've signed in as a student here. So this view should look like what you are seeing as well, called Code Along. So if you would like, you can start that project up and you can actually kind of see the beginning of this analysis, but I actually haven't started doing any of the analysis. We're going to do that together. While this project is firing up, I'll answer a couple of the questions that are that I'm kind of seeing in the chat. So R is a programming language that we're using. Somebody asked about Anaconda, which is I don't know, one way to distribute things like computational software. Yes, R is on Anaconda, but that is not relevant to what we're going to be doing. We are going to be asking you to use RStudio Cloud for your access to R, as opposed to downloading things locally on your computer. By the end of the semester, I'll say more about downloading things locally on your computer, but this allows us to exchange code easily, and also it allows me to control your computational environment, as opposed to helping you troubleshoot things on your local computer, which can be quite hard. This way I can actually peek into your projects and help you troubleshoot things easier. And Git and GitHub are the tools that we're going to use for version control. There is a video about how we're going to be using them. So if you are curious about what is Git, what's GitHub, go ahead and make sure that you watch that video, and tomorrow's workshop will clarify some of that a bit more as well. It is possible that you can't click on the links from the chat. If that is the case, I'm afraid not much that I can do. Sometimes Zoom has that issue. What you can do is go to RStudio Cloud, and then start the project. And once you start the project, you're going to see in our Markdown document called Himalayan Climbing, and the links that I shared with you are there as well. So I am going to go ahead and make my font size a little bit bigger here, just so you can see things a little bit better. Another thing I'm going to do is I'm going to change where my console shows up, because that tends to be make life a little easier for others following along with you on video. So now my console is up here on the upper right. And our Markdown document is here on the left-hand side. Okay. We're going to use the TidyVerse package, which is something we're going to almost always use. And I'm also going to load another package called Skimmer, which is going to allow me to take a look at these data sets. And I'll show you a little bit about how I'm using that in a second. So as I said, the data come from Tidy Tuesday, and you can read more about it. I have the links where you can read about these. And there are 3 files that I'm downloading and reading into R. They're called CSV files, which stands for comma separated values, which is a very commonly used way of sharing or storing plain text data. And the function that I use to read those is called read_CSV. So I mentioned before in the videos that our functions tend to be verbs. So here it's saying read CSV and read it from this particular URL, which goes to that Tidy Tuesday repository on GitHub that I showed you earlier. I have these in an R Markdown document, and I'm going to knit this document. When I knit it by default, I think it shows up in a pop-up window, and I'm going to guess that you're not seeing the output right now. Is that correct? I think Zoom doesn't pick up the pop-up window. So what I am going to do is I'm going to click on this gear icon and say preview in viewer pane. And I'm going to knit the document one more time. And now you should be able to see the document here, whoops, on the right-hand side. So this is what the output of the document looks like. Let's take a look to see what's going on here so we have a sense of the lay of the land of our Markdown documents. On top, we have the YAML, where we have some metadata, and that gets translated into like nicely rendered text that's like a header. In gray, with gray background that's denoted by these backticks, I have what we call R chunks. So your code goes into R chunks and your prose goes outside of R chunks. And so my R chunk is, has 2 lines of code, library TidyVerse and library Skimmer. There was a question earlier that asked, what's the difference between a package and a library? So these words somewhat are used interchangeably, to be honest, but in R, these units of reproducible code are packages, and library is the name of the function to load them. Now, wouldn't it be nice if this function was called load_package? It would be, but it's not, and we kind of have to live with that. But that's what that function is doing. And yes, if you make any sort of changes to the code, only you are going to be able to see that. That's not going to mess up anything for me here. As soon as you hit start on our Studio Cloud, it makes a copy that's only visible to you and also to me and the course teaching staff, but not to other students in the class. Okay, so these were the 2 lines of code. I knit the document, and then I see that it has some output for me, right? It's saying a bunch of stuff. So some functions in R will yield messages, and it's kind of messaging to the user about what they're doing. For example, the TidyVerse package actually loads 8 separate packages. So this is giving me a message about, here, you asked me to load this one thing, and I loaded these 8 things for you. These packages also happen to have some functions that coincide, that have the same name as existing functions in like baseline of R. And it's giving me some messaging about, hey, I have overwritten those functions for you, which is kind of nice that it's being honest. But I also really don't like seeing this sort of output in my write-up, because this is just like random messaging as opposed to data analysis output. So what I can do is I can add R chunk options. One of them is message, and I can say, okay, turn messages off for me. And now when I knit it, that stuff goes away, okay? Similarly, every time I read a data set, R is being pretty chatty about what are all the variables in this data set. For example, in the members data set, I have things like year, age of the person who climbed, whether they were hired or not, so on and so forth. And it's giving me all of this information in a that isn't very human friendly in a way. So I'm going to turn off the messaging there as well. And false does need to be capitalized, yes, because true and false are special binary values in R, and they do need to be capitalized. Okay, so now I have the Himalayan climbing expeditions, and I'm saying I'm going to load the data sets. Let's start looking at these data sets. So once you have a data set in hand, there are two things you can do to get started. One is obviously look at the data dictionary, and every data set that I give you will come with a dictionary like this, because you need to know what these variables mean. But also we want to look at it in R. For example, it says in the peaks data set, there's something called peak name. How many peaks are there? Like, we want to get a sense of how big are these data sets and stuff. And the way we can do that is we can actually, I'm going to insert a new R chunk. Would a dark theme be better if the background is dark? Is that easier for people to see? Yes, no? It's going to be kind of split, I think. Let's keep it like this for now, and then we'll try switching it for the next one. Okay, so there was another question here. Is there a shortcut to add the chunk like you did? So yes, we can either click on here on the insert button and add an R chunk, or there is a shortcut, one that I don't use very regularly, but I think, do you guys see insert chunk at all? Okay, so it looks like Command Shift I does that. So that would be another one you could try. I usually do this I use shortcuts for a lot of things, but for this one, I usually do this. So what I'm going to do is from the skimmer package, I'm going to use the skim function to, let's take a look at the members. And let's go ahead and knit this document and take a look to see what sorts of information I have. So we have, what is a chunk? So an R chunk is basically where we have where the code goes, versus everything outside of that is the is where your prose goes. So we call these areas that are gray in background and denoted with the 3 ticks R chunks. So the main body of your text goes outside of your chunk, and your code goes inside of chunks. So we have data from 76,119 people who climbed the Himalayan peaks. And we have 21 columns of data in this particular data set. The data set is coming from a database that a journalist based in Kathmandu has been maintaining for years and years. So some of the variables are character variables. So for example, the ID of the member, the name of the peak, the season where they did the climb, the sex, their citizenship, if they died, what's their death cause, stuff like that. We also have some logical variables. So these are either true or false. So this is hired is whether the person was hired or not. Success is whether the expedition was successful or not. And then we have some numeric variables, which are year, age, how high did they climb, if they died, at what height did they die. So we know some things about whether there was any missing data for these particular columns, what the average age. So for example, the average age of the climber is 37.33, and we can kind of see the shape of the distribution. And we'll talk more about what we mean by the shape of the distribution next week when we learn more about data visualization. Okay. This data does sound a little bit sad, and that is in fact correct. So what I'm going to do is I'm seeing something weird, like a rendering error. So I'm going to close this and open it again, so all my R chunks are highlighted, so I can answer a couple of the questions that are in the chat. How did the data get into R? using the function called read CSV, which goes to the URL and actually imports the data. So you can directly import the data from a website, or we could download the data and upload it onto our RStudio Cloud project. We'll talk about that option later in the course. So the data was not already present. We are reading it in from this URL every time we run the code. Yes, there will be step-by-step explanations. That's what we are going to start doing next week, basically. The data needs to be in a special format in the sense that if you're using the read_CSV function to load the data, it needs to be a CSV file, which is comma separated values. If it was formatted as something else, then we would use a different function for reading it in. However, we are going to mostly work with CSV files. So let's go ahead and knit this again. Yes, we are going to talk about all various ways of importing data in the R. That's one of the units that we will cover. I think one of the other questions that is coming up is about how do we hide the code from our output? And I'm going to show you how, but I'm also going to tell you for the time being not to do that, because when we evaluate your assignments, we actually want to see your code. But if I wanted to, you know, actually write up a report that is going to be consumed by someone who doesn't want to see the R code, I can add another chunk option called echo equals false. And what this does is it runs the code, and I know that it runs the code because this object called members is being used by the next code chunk, but it doesn't show it for me. So there is a way of hiding your code even though the document is still running it. I'm going to take this option out for now, just because I actually want to continue to see the code that I'm running. Okay. So one of the things that we might want to look at is what are the popular peaks. So let's take a look at the peaks data set as well. And see if we have peak names there or if we want to just use the members data set. So this is the, what I'm actually going to do is to make life a bit easier. I will say, this is a summary of the members data set, and this is a summary of the peaks data set. Let's go ahead and insert a code chunk and paste skim, which is the name of the function that creates this nice summary for us. And this is the name of the object that we store the peaks data set as. Okay, so in the peaks data set, I also have something like peak names. So let's take a look to see what are the various peak names and see if we recognize some of them. How might you go about, so I'm not asking you a coding question, I'm asking you to kind of think logically. So let's take a look at what this peaks data set looks like. Nope, not there. I'm going to open up my console and say view peaks. Load the data. Okay, and now let's say view peaks. If I wanted to find out what is the most common peak name, how would you go about doing it? And again, not a coding question, like if you were given this task and you were given this data set, what are the types of things you might want to do? Find the mode. So mode is a summary statistic that gives us the most common observation. That's correct. But mode is something that you would use for numerical data. So the things like mean, median, mode are defined for numerical data. But here we have character data. So it's not numerical. Maybe create an array which counts the occurrences of each name mentioned. That sounds like a good idea. So let's count the occurrences of each name mentioned. So how would we do this in R? I am going to create, put in a new R chunk. So some of you are saying for loops. That probably means that you have done some sort of coding before. And let me just tell you this, we're going to write 0 for loops in this course. And the reason is that there are other ways of approaching these problems without for loops that are vectorized, that actually allow us to work with data frames a lot more efficiently. So we will learn about for loops, but we're also going to learn about other methods for iterating over things through functional programming as opposed to using for loops. So, but before we do that, this sort of task is very common in data analysis. So we can actually do it using some functions that are built into TidyVerse. So what I'm doing here is I'm saying I'm going to start with the peaks data set. And I'm going to pipe that into a function. So I can read it as take the peaks data set and then count the peak names. Let's go ahead and run this code. And so what this gives me is how many times each of these particular peaks show up in the data set. And what would you guess, if you had to guess, which order is this peak name variable ordered in right now? Alphabetical, exactly. But what do we want? We actually want to know which one is the most frequent, not which one is the first that comes alphabetically. So I can add another argument called sort true. Oh, it looks like each one of these peak names literally shows up just once in the data set. That is interesting. Maybe that is because we're looking at the peaks data set, and in that data set, each peak name actually appears once. That might very well be the case because this peaks data set is about the peaks themselves, so it gives us information about them. So what we are interested in is what peaks are climbed most by climbers, and which one of these data sets has so we can either look at peaks or expeditions. Let's look at expeditions. So here each row is going to be a single expedition. So instead of using the peaks data set, I want to use the expedition data set instead. So I just changed the name of the data frame. And now I can see that Everest is the most common in terms of expeditions. Okay. So here each row was an expedition. What do you think I would get if I change this? Not in terms of what answer would I get, but what would this give me? So if I run this, what does this number tell me? How are these two numbers, 2149 from the expeditions versus 21,813 from the members data set tell me? Right, so the members is about how many people climb the peak versus the expeditions is about how many expeditions there. So this operator here is called the pipe operator. And basically what it does is it takes what comes before it and pipes it into the next function. So let me show you guys something. So let's keep this number in mind, 21,813 for Everest, right? So I'm going to change this code just ever so slightly. I'm going to take out that members, and I'm going to start with a function, and I'm going to place the name of the data set as the first argument and run this code. You can see that I get the exact same output. So basically what this means is that writing the code using the pipe operator or giving the name of the data frame as the first operator actually gives us the same result. So what that pipe operator is doing is it's taking what comes before it and plugging it in as the first argument in the next function. So a natural question might be is like, why would I want to do this first way instead of writing just a single line of code? And the reason for this particular example is not clear. But what if I wanted to keep building on things? So I can say start with the members and give me the count. So that's going to give me something like this. And then I might say, I don't actually want the counts, but I want the proportions. So what I might want to say is then give me a new column that's called proportion. And for that column, take the value n for each row and divide it by the sum of all n's. So this tells me that 28.5% of the people climbed Everest compared to the other peaks. So the function mutate creates a new column, and these are all things we're going to go through more methodically. But here, what I'm trying to exemplify through to you is that the pipe operator always takes what comes before it and plugs that whole result as the first argument of the next line. So it makes it easy to write data pipelines where you can build on it line by line, as opposed to if you were nesting your functions in a single line, it makes it a lot harder to read. So we are going to use the pipe operator very regularly in our coding, and it always means take what comes before me and plug it into the next line of code as the first argument. So how does it know that n is the count? Well, n is a variable that got created by the count function, okay? So what the count function does is it takes a look at the unique names in the peak name variable and counts for you how many times they appear, without doing things like you having to take care of writing, you having to kind of do the counting. R is doing the counting for you. And it always yields a new column called n that is the count. And what the mutate function does, whoops, I pasted it in the wrong place. What the mutate function does is it mutates your data frame, so changes your data frame in a way, adds a new column called proportion, and that column takes the value of n for each row and divides it by the sum of all n's, which is basically the sum of all, so the total number of members who did expeditions. Would sort equals false be lowest to highest? So that's a good question. Let's take a look. So how would I go about answering this question? What I would do is I would take a look at the help file for count, and I can always do that by saying count question mark count will bring up the help file for this, and it tells me that by default sort is equal to false. And let's take a look to see what it says about sort. If true, we'll show the largest groups at top. What happens if we do false? Does it actually give you the ordering the other way around? No. It actually just leaves things as it and sorts it alphabetically. But how might I want to, what if I wanted to see the least common as opposed to the most common? So what I could do is I could say, let's get rid of this. So my columns are peak name, n, and proportion. And I might say, maybe it makes more sense to put it here, arrange based on the value of n. And so that will actually arrange it based on n. So another way of getting to where we had sort equals true would be to say arrange it in descending order of n would have given us the same result that we had before. It's just such a common thing you might do that it's something that you can do by adding an argument to the count function as well. Now let's take a look at the people who succeed and who don't succeed the climb. Okay, so let's take a look at maybe whether people were hired or not. And okay, do you guys want to go grim or do you want to stay positive? Grim. Okay, great. So let's look at hired and died. Okay. I'll insert a new code chunk. So the people who are hired are the people who are like helping out with the expeditions, right? So in my members data set, I want to count the people whether they were hired or not, and whether they died or not. I know that these are the names of the variables from the data dictionary here. So hired stands for whether the person was hired by the expedition. So these are more like the Sherpas. And died is whether they died. Okay. So let's go ahead and run this. So what do we see here? We're seeing that of the people who were not hired, so of the people who were not hired, 788 of them survived, and I'm sorry, 788 of them died, and the rest survived. And of the people who were hired, 318 died, and the rest survived. So if the question is death rate higher among those people who were hired or among those people who are actually like doing the expedition not hired, I can't really compare these numbers, right? Because I have different sample sizes for the groups who were hired or not hired. So what I need to do is we would need to look at proportions. So what I'm going to say is, let's basically use the same argument from before to create proportions. Now, what am I looking at here? These proportions are basically telling me what proportion is 60,000 out of the total, what proportion is 788 out of the total, but that's not really what I want to find out. What I really want to find out is among the people who were not hired, what proportion died, and among the people who were hired, what proportion died. So I actually want this to happen once per hired category. So I'm going to say just group the data by whether people were hired or not, and then calculate the proportions for me. So now what I can see is that among the people who were hired, 2.2% of them died, versus if they were not hired, only 1.3% of them died. So it seems like the death rate is higher among the people, the Sherpas. And this is actually a thing that the local community in the Himalayas are in fact quite concerned with. Now, I want to show you one other thing, and then I'm going to take a look at the, so no, hiring doesn't necessarily kill people. I don't think it's a causal relationship, but that's a comment that's like useful to think about. But what it does say is that perhaps there's less value that's being placed in these people's lives, which is really not right, that they are trying to serve these people who are coming in to do the expeditions because that's what their economic kind of model is based on, but they are putting themselves in probably much riskier populations. What group by does is it makes sure that the next calculation that comes from it is done once per group. So what this did here is that calculate the proportion for me once per group who was not hired and once per the group who was hired. Another way of looking at this could be a visual way, and this visual way is actually what we're going to start learning about next week. So I'm going to turn this into a plot now. So I'm going to use a function called ggplot on the members data set. I'm going to say that on my y-axis, I want to have whether people were hired or not, and I want to fill in my columns. All right, let's do this first. And let's say geom bar to make a bar plot. So this is what is showing me the distribution of how many people were hired versus not. And we can see that fewer people were hired, which makes sense. Those are the people who are helping, probably one per group of climbers. But we're interested in looking to see how this varies by whether people died or not. So let's go ahead and do this. And so here we're comparing those counts, which is what we did at the beginning. And we said this sort of count comparison is not helpful because the two lengths of the two bars are different. So what I might do is I might say change an argument. And now I'm actually looking at those proportions. So the full length of the bars are basically 100%. And these tiny, tiny areas are showing me what percent of the people died. And they are tiny, but these are human lives. So it does make a difference. I don't think, anybody is going up there and thinking I am going to die here. It is a risky thing to do, but we're seeing that the effect of the death rate is slightly different for people who are helping others climb. Now, I've completely glossed over. How did I know this word AES needed to be here? How did I know position needed to be set to fill? These are things you might be thinking, how would I ever know to do this? And that's exactly where we're going to start next week with Learning R. So next week's unit is data visualization. And I am going to basically be assuming that you don't have any background in data visualization, but that you have some sense of what a data frame looks like, which is basically this. I have rows as observations and columns as variables, and take things from there and walk you through step by step of both how to create data visualizations and also what sort of data visualizations are used for what sorts of variables. Somebody asked, why is the bar chart on its side? Because that's how I like it, is my answer. But we could actually say put the X hired variable on the X-axis as opposed to the Y-axis, and I would get something that's standing up straight. I can't find a particular function, or I can't find the data set. That basically means that you haven't ran either the lines of code that load the packages or the lines of code that load the data. So let me show you this one thing. I'm going to restart my R session. So, if I now type members here, it tells me I can't find it. If I try to say, okay, give me this calculation that I did before, it says, I can't find members, I can't find this function. Why is this happening? Because I haven't loaded the packages that were needed for the function, and I haven't loaded the data sets that were needed to do my analysis. So one thing I might do is, I might say, okay, I want you to run everything up to this point for me. So I'm clicking on this run all chunks above. Let R do its thing. And then run this one for me. And then I can get the results that I want. Okay, so anything that's like peaks not found, members not found, all of that is going to be resolved by loading the earlier R chunks. So in summary, what we have seen is how to load data from a URL, some basic functions in R for taking a peek at your data, and just dipping our toes in how to do things like basic counting and basic data visualization. And what we're going to start with next week is actually the data visualization topic and build more on that throughout the first week. Then in the next week, we're going to go and do more of this sort of data pipeline stuff. And then come the next week, we're going to put the two of them together where you have to do a bit of visualization, build more pipeline, go back and visualize again. In terms of, do I recommend that you get the textbook? I think that's entirely up to you. Anything that I'm going to be assigning as reading is freely available online, but if you like having a physical copy in your hand, some people prefer that, then sure, you can purchase it, but otherwise I would say just reading online is perfectly fine. And the quiz will be available a little later today, and it's just going to be on course basics like syllabus and just the minor things from this week's videos. Nothing that will require you to run any code in R. And anything related to GitHub and RStudio Cloud will be covered again in tomorrow's workshop as well. And yes, there's a quiz. It's not graded. It's just to make sure you know how to get to the various things. All right, well, thanks for joining in. I am going to post the recording and also this file later today, and the RStudio Cloud project will stay there. So if you just watched but want to go back and kind of play around with it, you can do that. And as I said, if you want to see what others have done with this data set, this Tidy Tuesday hashtag is useful. And a lot of people, once they do things, actually share their code for how they did it as well. Some of this code will you know, undoubtedly be a bit above your head, but you might start seeing things that you're recognizing as the types of things you've already started learning about. All right. Thanks. I'll see you all tomorrow in the workshop.